Vectors GCSE A to A star exam question practice. I'm going to be doing 8 questions on vectors, and you can use the index on the right hand side on YouTube to jump between questions. Let's start with this question on a trapezium. So make sure you have a go at this question before I go through how to do it, and then you'll understand what I'm talking about. So we have to write AB in terms of A. So we're trying to do AB, which is this vector here, in terms of A's. And we know that DC is 6A. We're told that there, and we're also told that AB is 2/3 of DC. So if we want AB, the vector AB, we need to do 2/3 of DC, and we know that DC is 6A. Now when I write my vectors, I will put a little squiggle underneath the vectors, lowercase version A and B, just to denote that that's the vector. So 2/3 is 6, 1/3 of 6 is 2, so 2 lots of that is 4, so that's 4A. Now we're going to write M n in terms of A and B. Now to do that, I'm going to look at going around the trapezium from M to N. I want to go across to there, but I'm going to go this way using this vector plus this vector plus this vector. So to get Mn, I'm going to work out Md, and then I'm going to add on dA, and then I'm going to add on AN. So MD, or D to M, is 3A, because M is the midpoint of DC, and DC is 6A. So D to M is 3A, but we want to go from M to D. When we go the opposite direction, we need to change the sign, so that's going to be minus 3A. And then we're just going to go on dA, which is the vector B. We're told that there, so that's plus B. And then we're going to go along A to N, which is a half of AB, which is a half of AB. So we have minus 3A plus B plus a half of AB, and AB is 4A, so that's 2A. So minus 3A plus 2A is minus A, and we're adding B. Now we could leave it like that, but it's probably neater and tidier to turn them around so that we've got B minus A, which is the same thing. And there we go. Here we have a basic triangle question. Now I'm going to be quite formal when I write my answers down, but you can get away with being a little bit more casual. This one writes down the vector AC in terms of x and y. So AC is going to be AB plus BC. So AC is equal to AB plus BC. So we're going to go around the triangle. When you first start doing vectors, you think, well, what's the point in that? Well, that's how we do vectors. We follow the ones that we were given and we're told about to get to where we want to go. So we need to add AB, so AB is 2x, and we need to add on BC, which is 4y. And there we go, 1 mark. Next part, AC to CD is in the ratio 2 to 1. So AC, this part, is twice what this part is. Work out the vector AD in terms of x and y. So A to D is going to be A to C, which we just worked out, plus C to D. And we know that AC is 2x plus 4y. But C to D is a half of what AC is, so I'll just write that down in a bit more detail. So half of 2x plus 4y. And 2x plus a half of 2x, well, half of 2x is 1x, 2x plus 1x is 3x. 4y plus a half of 4y, which is 2y, is 6y. And there we go. Now it does say give your answer as simply as possible, and you might be tempted to think, well, there's a factor of 3 there, I could just divide by 3, but you don't do that. What you could do, just to tidy up a little bit, is to put a bracket in there and factorise out the 3. but 3x plus 6y is probably enough there. Okay, we have a trapezium question. Fairly standard trapezium question, apart from this ratio here. Normally ratios on vector questions split lines in a certain ratio, but this is telling us the line zy, so this line zy is in the ratio to wx, in the ratio of 3 to 2. So if this line is 3 long, this line is 2 long. But we're told wx is s. So zy is going to be 1.5 times wx. So if we want zy, which is what we're trying to find here, we need to do 1.5 or 3/2 lots of wx. And wx is just s, so that's just 3/2 s. Now with vectors, you should really leave it in fractions, and top-heavy fractions are much easier to manipulate them than mixed numbers. So I would leave it as 3/2 s. Work out the vector xy in terms of s and t. So xy is x to y is that vector there. So we're looking at trying to do that vector, x to y. And we've got to do it in terms of s and t. So what we actually got to do is we've got to go backwards along this line, down along t, and then along this line here to get to there. So we're going round the outside using what we know. So we're going backwards across s in the opposite direction. So we need to do x to w, and then we're going to go from w to z, and then we're going to go from z through to y. Now we know xw is the opposite of s, which is minus s. We're going to go down wz, which is just t. Coming down here is just t, and then we're going to go along zy, which we just worked out to be 3/2 s. So adding that together, minus s plus 3/2 s is just a half s, and then we're going to add on t, and that's in its simplest form. Okay, so we've got a tricky triangle question. It's tricky because there's lots of fractions involved, and it's not the m that we're going to be using is part of the way along a line that's not on the two main vectors. So we're going to do L to K. So we're trying to work out this vector from L to K. Now to do that, probably the easiest way to do it is to go from L to U and then from U to K. Now we know, or we are told, that UK is 2/3 of UV. So this is 2/3, and this bit down here is 1/3 if we need that. And we're also told that L is on OU, so that OL is 3/4 of OU, and LU will be a 1/4. Now OU is U, so this 1/4, let's actually write this down, LK equals LU plus UK. That's what we're trying to use to get from L to K. So LU is just going to be 1/4 of U, because that's 1/4 of that whole line, and it's in that direction, which is U. So we've got 1/4 U plus UK. Well, UK we don't know, but we can work out UV, and we want 2/3 of UV. Now UV, I'm going to do it over here. UV is your standard triangle question where you go down the opposite way of U and then across V. So minus U plus V. Often that's written as V minus U, just the other way around. So we've got 1/4 U plus 2/3 of V minus U. So we've got 1/4 U minus 2/3 U. So we've got 1/4 U minus 2/3 U, and that's why it's a little bit tricky because there's some fractions involved. And then we're going to add on 2/3 V. So 1/4 U, 2/3 U. If we change that to twelfths, we get 3/12 U by timesing by top and bottom by 3, and then times this one top and bottom by 4, we get 8/12 U. Oops, 2/3 V. And then 3/12 minus 8/12 is minus 5/12 U. I'm going to put this on this side. I'm going to put the minus on the right hand side. Minus 5/12 U. You could write it at the front. And then there's 2/3 V, but it's tidier to put the minus in the middle. So that's our LK. Now O to M, we're going to look at this one here, O to M, but we're going to go along O to L and then L to M. We already know LK, so we can work out LM because M is the midpoint of LK, so that means it's halfway across there. So OM is going to be O to L plus L to M. And O to L is just the 3/4 of U, as it shows on the diagram, plus a half of L to K, which we've already worked out. So we've got 3/4 U plus a half of 2/3 V, this is our answer from over here, LK, minus 5/12 U. Okay, so getting a bit tricky there with the fractions, but we should be able to deal with that. 3/4 U, a half of 2/3 is 1/3 V, and a half of 5/12, so I can't half the top there because that would be 2.5, so what I'm going to actually do is going to double the bottom to make it half as big, so 5/24 is half of 5/12 because you've made each fraction half as big. So we've got 3/4 U minus 5/24 U, so we need to change the 3/4 into 24ths. By times them by 6 we have 18/24. Top and bottom by 6 minus 5/24 U plus 1/3 V. So 18 minus 5 is going to be 13/24 U minus, plus 1/3 V. And that's quite a tricky question. The fractions make it difficult, not so much the vectors. Okay, here we've got a trapezium question, and we've got the beginnings of a straight line proof. We've actually just got to find the value of K when these two are parallel, and that's essentially the beginnings of proving that TSQ is on a straight line. But anyway, let's start with the beginning. PS, trying to find P to S, which is this line here, and we are told that PS is 4 lots of QR, so that's going to be 4 lots of Q times R, and Q times R is B, so that's just 4B. P to R, P to R is that line there. Okay, and do look at which directions the arrows go on your vectors. I think the first time I did this, when I looked through it, I actually got the signs wrong because I thought one was minus, but from P to R we're going to go from P to Q, and then we're going to add QR, so that's A plus B, nice and straightforward. And then R to S, we're going to go along that line there. Let's use a different colour, R to S. And to do that, you can see the two vectors we found here. We need to go down this one the other way, so minus PR or RP. So that's going to be RP plus PS, and RP is minus PR, so that's minus A minus B plus PS, which is 4B. So we end up with minus A plus 4B is 3A. No, that would be they're B's, aren't they? Minus A plus no A's is minus A, and I'm going to put the minus A on the end. Minus B plus 4B is 3B. Let's get it right. 3B minus A. I'm just going to move this part of the question up a bit to give me a bit more space, and this one over. Okay, now the point T lies on the line PR. PR such that the ratio PT to TR is 4 to 1. So this part is 4 times as long as this part. So what that tells us is this is 4/5 of the line and this is 1/5 of the line. So given that TS, that's the point T, TS we'll use the green one again. T to S is a multiple k lots of qt, q to t. Find the value of k. Now when we're trying to prove it's a straight line, if we can find qt and qs, then we can prove, and one's a multiple of the other, that pretty much proves it's a straight line, and we'll deal with that in another question later. But here we go. TS, let's find TS. So from T to S, we need to come down 4/5 of RP. Or we could, yeah, let's go down 4/5 of RP. Let's come this way. And then along there. So TS is equal to TP plus PS, and TP is 4/5 of RP, and PS we know already is 4B, we've got that up there, part 1. RP is the opposite of PR, so that's 4/5 of minus A minus B. It's the opposite of A plus B plus 4B. So we've got minus 4/5 A, we've got minus 4/5 B plus 4B. Now I'm actually going to change that. Well, that's 3 1/5 B. But I'm going to look at this in terms of fifths, so that's going to be minus 4/5 A plus 3 5s are 15 plus 1 is 16/5 B. I'm going to do that because it's going to be easy to spot what we've got to multiply by to find K. So let's look at QT. Now QT, we're going to have to come down minus A and then go up. So we're going to go down QP and then we're going to add PT. So QP is minus A, and then we're going to add on PT, which is the opposite of what I just did down here. So it's going to be 4/5 of A plus B this time. So we get minus A plus 4/5 A is minus 1/5 A, and then we've got 4/5 B. And hopefully we can see a connection here. What do we multiply this one by to get that one? Well, 4 times 1/5 is 4/5, and 4 times 4/5 is 16/5. So that shows us that, therefore, TS equals 4 lots of QT. So K equals 4. Okay, here we've got a question with a parallelogram, and here's the first example of a straight line. Using the vector method proves a straight line. We'll do the preliminaries, the working out the basics. So PS, P to S. We're told PM is A, and M is the midpoint of PS. So PS is just going to be twice A. Don't need anything more than that. PR, going across from P to R, well, I need to come down PS, then across SR. Because this is a parallelogram, this is also the same as the one opposite, which is B. So PR is going to be, let's put a bit of detail on this, so PS plus SR, and PS is 2A plus SR, which is B. Okay, now we've got to MQ. Now MQ, I'm going to go this way, I'm going to go up to P and then across to Q. So MQ, I'm going to go MP plus PQ. Out of all these vector questions, you can go other ways. You could go the long way around, but it just makes sense to use the shortest route since they're already labelled. M to P is the opposite of A, which is minus A, and P to Q is B. So that's going to be B minus A. I could leave it as minus A plus B, there's nothing wrong with that. But it's tidier to have the negative in the middle. Right, so now here we go. N is the point on MQ such that MN is a third of MQ. So M is on here, so that is 1/3, and this is 2/3. And we need to prove, or we want to, that PNR, okay, if it's drawn properly, is a straight line. So let's move that along a little bit there too. Okay, you've got to prove that's a straight line. To do that, to prove something's a straight line, we need to show Pn is parallel to PR. Now, why does that show that's a straight line? Well, if two lines are parallel, but they start from the same point, they must be the same line because they go in the same direction and they start from the same point. One is just longer than the other. To show they're parallel, we need to show, so that implies we need to show that PR is equal to something times Pn. If we can show that PR is a multiple of Pn, then we prove they are parallel, and in so proving they're parallel because they've got a common point, they must be the straight line. So what we need is PR, but we already have PR. PR is 2a plus b. So we need to work out Pn. Now P to N, I'm going to come down from P to M, and then I'm going to go across from M to N. P to M is just A, and then M to N is 1/3 of MQ. And luckily we worked out MQ up there, which is minus B plus B minus A. So we've got A plus 1/3 of B minus A. And that gives us A plus 1/3 of minus A, so that's taken away 1/3 A. So that's 2/3 A. We've got 1 take away 1/3, and then we've just got 1/3 B. So PR is 2A plus B, and Pn is 2/3 A plus 1/3 B. So if we times Pn by 3, we'll get PR. So PR equals 3 lots of Pn. Therefore, PR and Pn are parallel. And since P is a common point, PNR forms a straight line, and that's all we need to do. Okay, here we've got another proving straight line using the vector method. This time in a rectangle, slightly trickier than the last one I did, but always we start with some vectors we're given. So find in terms of A and B, OQ. So O to Q, well, what do we know about what we're given so far? So we know that OD is A, and we know that D is on the point OP, such that OD is 1/3 of OP. So this is 1/3, this is 2/3. Okay, because this is a rectangle, we can say this is 3B because it's opposite this one, so it's the same. And we're also told that PQF in straight lines such that QF is 1/3 PQ. So QF is 1/3 of PQ, and PQ is 3B, so that vector there is 1B. Okay, so OQ, we need to go across here. So if this is A, this bit here must be 2A because it's twice as big. So OQ is going to be OP plus PQ. So that's 1A plus another A is plus 2A is 3A, plus PQ is 3B. So 3A plus 3B. Then we've got to do OE. We're told OE is such that OE is 2/3 OQ, so that's 2/3, 1/3. We just worked out OQ, so this is going to be 2/3 of OQ. So that's 2/3 of 3A plus 3B. and 2/3 of 3a is going to be divided by 3 gives you 1 times by 2 is 2, and 2/3 of 3 is also 2, 2b and 2b. DE, so we're going from D to E, from here to here. Best way to do that is to come back from D to O and then add on OE. So we're going to go via DO plus OE, and D to O is minus minus A, because we're coming back in the opposite direction, so that's minus A, and then OE we just worked out as 2A plus 2B. So that gives us minus A plus 2A is A and 2B. So 1 mark for each of those. Use the vector method to prove DEF is a straight line. So DEF is a straight line. What we need to do is prove DEF is equal to something times DE. And that will prove that they are parallel, and because they share a common point D, parallels that share lines that share a common point are collinear or straight lines. So DEF, straight line, we need DF, and to do that I'm going to go from D to P and then from P to F. So we're going across D to P and then P to F. D to P is going to be work that out to be twice this one, so that's 2A plus PE is 3B plus B, which is 4B. So 2A plus 4B, and D to E we already know. So is this one a multiple of that one? Well, if I times this one by 2 I get that one. So just to show that, we need to do DF equals twice DE, therefore parallel. And since both share a common point, DEF is a straight line. Okay, another one. Similar idea to the last one, and pretty much the same for all these ones. We've got to prove there's a straight line. Okay, here we've got a trapezium question again, but this time we're going to try and prove something is a parallelogram. To prove that OACM, so this shape here, is a parallelogram, I need to prove opposite sides are parallel. So need to prove OA parallel to MC and OM parallel to AC. Now OA is parallel to MC. We're told that up here because BC is parallel. Since BC is parallel to OA, that implies MC is also parallel to OA. So all we have to really do is to prove OM and AC are parallel. Normally to prove things are parallel we just need to say one's a multiple of the other, or in this case it looks like, well, it's clear that we've got to prove they're just the same vector. So if we work out what OM is going to be the vector OB plus BM, and we know OB is B, and we know BM because M is the midpoint of BC, and BC is twice OA. That implies that BM is A. So OM is B plus A or A plus B. I need to look at AC. Now this one we're going to have to go around the house a little bit. We're going to have to go from A to O, then O to B. We could go OM, because we just did that, but I'm going to just stick to the standard ones, and then B to C. So AC is going to be AO plus OB plus MC. A to O is minus A, because it's going back the other way, minus A. OB is going to be B, and MC, not MC, that should be BC. BC is going to be twice A. So we've got minus A plus 2A is A plus B. And since OM equals AC, they are parallel. So OACM is a parallelogram.